Good morning. Welcome back. Hopefully everyone had a great weekend and did great on their quiz. So if you're looking at this is not the incorrect notes. We are doing 12.1 because it just flows nicely with what we had been working on before with graphing and linear equations and all that just flows with this. So you guys know how to solve systems, I'm sure, but we're going to add like one little twist to this, and it's just a couple of little vocabulary words that we want to make sure you guys are comfortable with. So, consistent system is one solution, a system with independent equations, and one point of intersection. So there's two kinds of consistent systems. There's a consistent that has one solution, and there's a consistent that has infinitely many solutions. So if you have to classify it as consistent or inconsistent, know that consistent, which makes sense, thinking about it in terms of what comes naturally, consistent makes sense that it would be a solution. So now the difference between one solution and infinite many solution is if when you solve it, you get an identity, or you get all your variables are eliminated. Then you know it's infinite many solutions. But whereas if all the variables are eliminated and you get something that doesn't make sense, we call it an inconsistent or no solution. So a system with dependent equations where the lines coincident, creating infinitely many points of intersections. So what we're going to do differently, whereas before in advanced algebra or even freshman algebra, you would just say, okay, infinite many solutions. This time we are going to solve for x and say y is any real number. And I'll show you guys what that looks like because that's how you get to write your answer in Math Excel. The third situation is when you have an inconsistent system, or it's no solution. And it's a system where the lines are parallel, creating no point of intersection through all the equations of the system. So the title here is substitution and elimination, but honestly, I really strongly feel that elimination is the best method. So looking at all these, they're kind of all set up for elimination except for C. But all the rest of these, when you have it in standard form and the variables line up perfectly, this is the perfect situation to do elimination. So looking at example A, all we got to ask ourselves are, pick a variable to eliminate. So that's your first thing, okay? So pick a variable to eliminate. There is no wrong answer, although sometimes there's one that's a little bit easier. So looking at 4x minus 6y equals 5 and 1/2 x minus 3y equals negative 1/2, you might be looking at this thing, man, I really don't like the fractions, but there's a nice relationship between negative 6y and negative 3y. So let's go ahead and get rid of the y's, because all I have to do is multiply the denominator, or the bottom equation, by negative 2, and then I have opposites. So that's the next thing, is multiply by a constant to create opposites. So I'm going to multiply this bottom equation by negative 2. And now when I rewrite this, I get 4x minus 6y equals 5, and negative 1x plus 6y is equal to 1. And if you just look at this, you see that these are opposites. So we're going to add, so we call this elimination by addition here. We're going to add these two equations together, and I'm going to get 3x is equal to 6. So pick a variable to eliminate, multiply by a constant to create opposites, add to eliminate, and then we're going to solve. So I'm going to divide both sides by 3, x is equal to 2, and solve and find remaining variable. So I know that x is 2, I'm not done. I have to substitute it back into an original equation. So either this one or this one, whatever's easier. To me, if I can avoid the fractions at all costs, I'm sure you guys feel the same way, I'm going to do that. So I'm going to substitute it into the top equation here. So that's 4 times 2 minus 6y is equal to 5. 8 minus 6y is equal to 5. Negative 6y is equal to negative 3, y is equal to 3 over negative 6, or 1/2. And so now I'm going to write my solution as 2 comma 1/2. Don't forget to do that. Don't just say x equals 2 and y equals 1/2. You have to write it as a solution. And then the last step, which is the one that most high school students do not like to do, is check. So I'm going to substitute these back in, and I'm going to see if they work. So let's see. 4 times 2 is 8, and negative 6 times 1/2 is negative 3. 8 minus 3 is 5. That works. 2 times 1/2 is 1. Negative 3 times 1/2 is negative 3/2. Negative 3/2 plus 2/2 is negative 1/2. Okay, good. So it does work. So please make sure you're checking your answers. I know there's a calculator program that will, some of you guys have it, the ACT program in your calculators that will solve the systems for you. I do want you to show work though, so regardless if you're using that program or not, you got to give me something. Don't just magically give me this answer and say like, oh, look, I did it. Okay, I'm not going to buy it. But you can easily check your work and make sure that you're doing it correctly. Okay, so let's look at B. So B, we have, again, look for opposites. So 2 and 3, they could work, right? But you know what works better is if I just multiply this top by 4, then I create an opposite with the y's. So now I get 8x minus 4y is equal to 4, 3x plus 4y is equal to 18. These are eliminated. I get 11x is equal to 22, x is equal to 2. And now I substitute it back into any one of these. It doesn't matter which one. I'll do the top one again. So now I'm going to substitute x for 2 in there, and I get 2 times 2 minus y is equal to 1, 4 minus y is equal to 1, negative y is equal to negative 3, y is equal to 3. And now I write it as a solution, 2 comma 3, and then I check. All right, let's see. 2 times 2 is 4. 4 minus 3 is 1. That works. 2 times 3 is 6. 4 times 3, 3 times 2 is 6. 4 times 3 is 12. 6 plus 12 is 18. That works. Okay, so please make sure you're doing the check to make sure you're doing this correctly. All right, so now looking at C, this is the one time where I'd say, you know what, let's go ahead and do substitution here. So I'm going to substitute for, I'm going to solve for x. So x is equal to 12, and then I'm just going to substitute it into this equation here. So this is 12 plus 2y is equal to 0, 2y is equal to negative 12, y is equal to negative 6, and then write our answer, 12 comma negative 6, and then check it. Well, the first one, 12, I already knew that from here, so I don't have to check that. But over here, 12 plus 2 times negative 6, that's 12 minus 12, is equal to 0. So that works. All right, so now, anytime, pause, try these on your own, but I'm going to keep going, and I'm trying to honor your time and keep this under 25 minutes if possible. All right, so looking at D. Okay, hopefully you guys see you really can't go wrong with whatever you substitute. So let's substitute and change the 2x to a negative 10x. So I'm going to multiply the top one here by negative 5. So that's negative 10x minus 5y is equal to negative 50. Sometimes the problem with elimination is students sometimes forget about this last term. Please don't do that. Make sure you distribute it to both sides. And now the bottom one, 10x plus 5y is equal to 15. And when I add these together, this is 0, this is 0, and I get 0 is equal to negative 35. That's weird. This answer does not make sense. So when we see something like this, this tells us that this is a no solution. But now using our fancy words up here, we say it's an inconsistent system. Inconsistent system. Okay, so I wanted you guys to get used to that new vocabulary. Okay, now over here with E, if you look at it, okay, I have x and I have 8x. Anytime you have something like this, I always feel like that's your go-to. So multiply the top by negative 8, because then it's so much easier to manipulate x. So now I get negative 8x minus 24y is equal to negative 48. 8x plus 24y is equal to 48. And I add them together, and 0, 0, okay, 0. So 0 equals 0. Now this is a true statement. When we see something like this as a true statement, we say this is infinitely many solutions. And that tells us it's a consistent system. Now the difference here, in regular algebra, your teacher would say, okay, you're done, right? In college algebra, we got to go whoa, no, stop. In college algebra, we got to go further. And we have to say, okay, what does x, what is x? So we're going to solve it. We're going to get x by itself. So now x is equal to negative 3y plus 6. And then we say y is any real number. So you'll see kind of this notation here in Math Excel, and we're kind of going to be expecting the same thing here. So make sure then, instead of just saying infinite many solutions and being done, we actually have to solve for x in terms of y. So x in terms of y means x equals negative 3y plus 6, and y is any real number. All right. Over here, I'm just going to set it up just to save time. I'm not going to finish solving it because I think you guys get the hang of this. So I have 1/2 x plus 2/3 y equals 4, and 1/4 x minus 4/3 y equals negative 3. If I multiply the bottom by negative 2, then I'm going to get 1/2. I'm going to get the opposite of 1/2. So now I have 1/2 x plus 2/3 y is equal to 4, and negative 1/2 x plus 8/3 y is equal to 6. And you guys can finish solving that one for fun later. All right, so now, kind of new. I don't know if you guys did this in advanced algebra. 3 variables with three equations, 3 unknowns. Okay, so what we're looking for is trying to work backwards here and do something called back substitution. So I'm going to try to eliminate the same variable and kind of substitute it back to create a 2-variable system with 2 equations. So looking at this, I have x minus y is equal to 2, 3x minus 6z is equal to 15, and 3y plus z is equal to 9. So if I were to choose, I want to pick something that's pretty easy to solve. And looking at this, I could solve for x here and get it in terms of y. And then if I substitute it into here, and it's in terms of y, then it's a lot easier to work with just these bottom 2 equations versus trying to guess and see what the answer is. So I'm basically, and there's, again, no wrong way of doing this, but I'm trying to solve for a specific variable, and that way I could create 2 equations and 2 unknowns versus 3 equations and 3 unknowns, which is really hard to solve. So looking at this top equation becomes x equals y plus 2. And then I'm going to use that top equation and substitute it in for x here. So this is going to be 3 times y plus 2 minus 6z is equal to 15. And now if you look at this, you're like, well, it's still kind of confusing. You got all these variables, but not really. I only have 2 variables which match these 2 variables down here. So if I just kind of finish solving this, I get 3y plus 6 minus 6z is equal to 15. 3y minus 6z is equal to 9. And I use the original equation, and I just work with these 2, and now I just created a system of 2 equations with 2 unknowns. 3y plus z is equal to 9. So let's go ahead and create our opposites like we did in the past problem. So I'm going to multiply everything in this bottom equation by negative 1. So now my new system is 3y minus 6z is equal to 9, and negative 3y minus z is equal to negative 9. This is eliminated. This gives me negative 7z, and this is equal to 0. And don't think you're doing anything wrong. 0 is a number. So we're good. If I just solve for z, divide both sides by -7, I get z is equal to 0. So that's my first equation. And now I could use this, and I could go and back substitute to find the rest of them. So like, look at the second equation here. This just has z and x. So if I substitute 0 in for z, I could solve for x pretty easily. So now this becomes 3x minus 6 times 0 is equal to 15. 3x is equal to 15. X is equal to 5. So now I have z, I have x, and I'm just missing y, but look at this top equation again. That has an x and a y, so let me back substitute and solve for y. So now 5 minus y is equal to 2, negative y is equal to -3, y is equal to 3. So now I have x, y, and z, and we write this in alphabetical order. So there's something called the XYZ plane. And when I write it in alphabetical order, my answer is going to be 5, 3, 0. And you could check. All right, I'll let you guys do the check for fun on your own, but it works, trust me. Okay, so again, looking at B, let's pick one variable to eliminate, and we may need to look at 2 or 3 equations at a time here. So now, let's say we want to get rid of, if I'm looking at this, look at these x's. You have 2x minus 2x, and you have x, which is easy to manipulate. So now, if I add these two together, I'm going to get a new equation that's in terms of just y and just z. So if we kind of call these row 1, row 2, and row 3, if I add row 2 plus row 3, then I'm going to get a new equation that's just in terms of y and z. So let's do that first because that's the easiest one to pick out. And all I need is 2 of those equations, and I could solve for y and z pretty easily. So let's see. 2x plus y plus z is equal to 4. Negative 2x plus 3y minus 3z is equal to negative 10. So if I add these together, this is eliminated. I have 4y minus 2z is equal to negative 6. Okay, save this. Save it for later. We're going to kind of work off to the side with that. Now if I look at R1 and R2, okay, or even R1 and R3, I could do the same thing, manipulate this top equation, and solve for again y and z. So let's go ahead and do 2 times row 1. So now my new row 1 is going to be 2x minus 6y plus 8z is equal to 18. And row 3 is already have an opposite of negative 2. Negative 2x plus 3y minus 3z is equal to negative 10. And when I add these together, the x's are eliminated, which is exactly what I wanted. I get negative 3y plus 5z is equal to 8. And look at this. I have 2 equations that just have 2 unknowns. I have a y and a y, a z and a z, and now I could solve these and then work backwards and find x. So let's create our new system, which is 4y minus 2z equals negative 6, and negative 3y plus 5z equals 8. And again, we're going to use elimination because I feel like it's the neatest and easiest to use. So looking at these, it doesn't matter which one you pick. So if I just want to get rid of the y's, I got to find something common between 4 and negative 3. And what always works is just multiplied by the other number. So I'm going to multiply the top by 3 and the bottom by 4. They're already opposites, so that's going to be easy to work with. So now this becomes 12y minus 6z equals negative 18, and negative 12y plus 20z equals 32. Y's are eliminated. Negative 6z plus 20 gives us 14z, and negative 18 plus 32 gives us 14. And now I solve for z. Z is equal to 1. All right, now I'm going to work backwards and find y. So plugging 1 into, doesn't matter which equation, let's just go ahead and plug it into this one right here. So I have 4y minus 2 times 1 is equal to negative 6. 4y is equal to negative 4. Y is equal to negative 1. Okay, so I have z, I have negative 1. I just need to find x. And if I put it into this top equation here, because x is already 1x, which is easier to work with, so this is going to be x minus 3 times negative 1 plus 4 times 1 equals 9. And now I have x plus 3 plus 4. So that's x plus 7 equals 9. X is equal to 2. And so now in alpha order, I have x, y, z. And you can check it, and you see it does work for all three of these, which is kind of neat because it's like a pretty tough system. All right, so try C on your own. I'm going to go ahead and do this together with you guys. And hopefully you see something glaring here. You see that you have a minus z and you see you have a plus z, and your bottom equation just has an x and a y. So right away, let's take care of these. Let's add these two together to get rid of our z's, and then we're going to create a new system. So we have x minus y minus z is equal to 3, and 3x plus 7y plus z is equal to 3. So look at these z's, they're opposites already. So I get 4x plus 6y is equal to 6. And using this one here, I get 8x plus 12y is equal to 0. And we could create opposites pretty easily. Sorry, this should be an x. So let's create opposites by multiplying the top by negative 2. So I get negative 8x minus 12y is equal to negative 12. 8x plus 12y is equal to 0. And look at this. 0, 0, negative 12. So I get 0 is equal to negative 12, which tells me there's no solution. Inconsistent system. Okay? So this is my redo on this problem. When I read it, I didn't read it carefully, which happens, right? It happens to everybody. Cashews are $5, peanuts are $2.50, and we know that it's 50 pounds of peanuts with some cashews. So when I read this, I first thought it was peanuts with some cashews is 50, but it's 50 pounds of peanuts with some cashews, and the mixture is $3 per pound. So X is going to be the cashews. We'll call it C. Y is going to be the peanuts. We'll call it P. So now if we look at the pounds and usually when we do these kind of problems, there's a quantity equation and there's like a money or a value equation. So the quantity equation is how much of each. So I actually know that there's 50 pounds of peanuts. So it's cashews plus 50 pounds of peanuts is equal to M, the mixture that we don't know because we don't know the total. And then for the money equation, we know that peanuts are $2.50 a pound and cashews are $5. So it's $5 plus the cashews times the cashews plus $2.50 times 50 for the amount of peanuts equals, so now the mixture is a total of $3 per pound, so that's 3 times, so the mixture is equal to C plus 50, so that's C plus 50. So notice how everything kind of lines up, this with this, 50 with 50, cashews with cashews. All right, so now that we have it lined up, we're going to go ahead and solve this, and notice in this bottom equation, there's only one unknown. So I could find the number of cashews and then figure out how much the mixture is total. So let's go ahead and simplify this. So that's 5C plus 125 is equal to 3C plus 150. And now I'm going to solve for C. So subtract 3C, subtract 125 from both sides. I get 2C is equal to 25. C is equal to 12.5 pounds. So there's 12.5 pounds of cashews. So 12.5 pounds of cashews. And that's what they asked us to find. How many pounds of cashews should be mixed with peanuts so the mixture would produce the same revenue as selling the nuts separately? Okay, this is my edit to this question, and if you have any more questions on these, we'll see you guys in class. Bye-bye.